Synthetic aperture radar. This is for the module of avionics systems. My name is Kushal Gopikaramanan, and my SRN is 1805908 2. To start off, uh, in today's lessons, hopefully by the end of today's lesson, we'll be able to answer what are synthetic aperture radars, why are they so successful and used by many aircrafts, how do they work, and what sort of images can they capture. So essentially, what are synthetic aperture radars? So synthetic aperture radar is a type of radar that is utilized to make two-dimensional pictures or 3D pictures of items, landscapes, blah blah blah. We'll get into more of that later on, but this is a picture of a synthetic aperture radar right here, attached to the bottom of an airplane. Probably some defense aircraft right now, looks like it. But yeah, so generally they are attached to the bottom of aircrafts like this. And this is an example of a synthetic aperture radar. So what are the uses of synthetic aperture radars? So there's predominantly two uses: military applications and scientific and research applications. In military applications, obviously there's surveillance, reconnaissance, targeting, etc. But they're also used by geologists and environmentalists to find oil, oil leaks and blah blah blah, and ocean topography to find like the ocean bed flow, to find underwater volcanoes, everything. So they're used for like a lot of research purposes also, and not just military. But we will be talking about predominantly the military use of these. So, synthetic aperture radar, as you know, as I stated before, it has a lots and lots of like military use predominantly. They're one of the most important airborne imaging sensors for surveillance, reconnaissance, and precision targeting. And this is according to DRDO. And so DRDO is a defense research and development organization of the Indian Defense Ministry, and they claim that SAR is an integral part of their operations. And that's because no matter what time of day, SAR can be used, and no matter what weather, they can also be used. Unlike some electro-optical thermal counterparts, this can actually be deployed anywhere and anytime. Uh, it has the capability to find roads buried deep inside forests and is able to like, show movements in vehicles, which I have an example of a picture later on. So then this would serve integral as sharing borders with many countries from which terrorists, like cross borders and set up camps in deep forests. The SR would prove vital in getting to know the size of the camps, the secret paths, etc. And not just the DRDO, even the U.S. Air Force loves using these radars, especially in the UAVs. In one such UAV, the RQ-4 Global Hawk, which is developed by the Notebook Group, it has this integrated sensor suite where it has synthetic aperture radar, and it's known for its reconnaissance, and that's only caused because of the SRR that's inside the airplane. As you know, the SARs don't have a limited range. Also, the aircraft can fly at very very high altitudes over clouds and still be able to get a clear image of the ground and to be undetectable by others. And the technology of synthetic aperture radar, which has been used to map the Earth from space, will play an integral role in the U.S. Departments of Defense's space-based radar programs in the near future. So now, how do they work? This is a big textbook definition, which I'm not going to bore you guys with. So I'm just going to give you the short form. So essentially, SARs are used to create an image by sending out radio waves down and receiving them back. And like I said, they're called synthetic aperture radar. So it is a type of radar. And a radar is like a function framework which creates its own radio waves and communicates them from its receiving antenna towards a target area. Basically, there's an antenna, it shoots out radio waves, and then it reflects, and then it monitors it back. So now again, depending on the properties of the target and image geometry or the angle and all the little settings you put in, the antenna will either receive all the radio waves, some or none of the radio waves energy on the way back when it detects it. So this is called detection. Once it sends it out, that's amplifying it, and then it gets it back, and that's detection. And all these received signals are then put together to make an image. And then this radar then can be attached to an airplane or a satellite and be flown over places to capture the image of the ground. So again, so the ground is then scanned by two different dimensions. It's called range and cross range, or also known as the azimuth. In the azimuth section, objects are scanned and placed in this dimension according to the position of the aircraft along the track. So as the airplane moves, the radar scans the ground, and whatever energy gets reflected back, which it detects, is then alongside a computer is mapped together, and it then an image is created. That's basically how the SAR works. So then again, yeah, so these signals then get put back together, and that's how an image is formed. And this is just a small diagram to show you like what I'm talking about. So like if this is the radar flying over a target area, it sends out radio waves and it detects them back as it's flying over. And again, this is a little sketch which I drew just to make it a little bit more clear that this is the flight path and this is the target area which is scanning. So as it's flying over, it maps it and it comes back, and so it sends out and it comes back, and it then gets placed as the aircraft moves along. It gets placed in a track, so then all the images come together to make one big image. And so these are the types of images that can be created by synthetic aperture radars. So on the top, this is like a normal optical camera on top of like on an aircraft. Just take a picture. That takes a picture, and this is from a synthetic aperture radar. Immediately, you can see the difference. This looks just like a normal field. Probably looks like a farm. However, with the help of the SARs, you can see that there are certain paths, different things that's going on, which can't be seen by optical cameras, whereas the synthetic aperture radar can find these out. So yeah, so that's what I meant by like they can be deployed anytime, anywhere, because they can detect anything that's underneath them. So in conclusion, well, synthetic aperture radars have revolutionized national security and has increased safety and surveillance. Like especially with like terrorism on the like in this day and age with terrorism, that's still being there. Just knowing what's going to happen before it actually happens can actually save a lot of lives. Just imagine knowing what like the enemies are up to, knowing what type of vehicles to have, knowing what type of movements they're going to be doing before they actually do it, or like before you come to know, before it's too late. So the element of surprise here, it's kind of lost, and it's actually good in terms of national security and safety. Again, I'm going to go back to those terrorist camps that are buried deep inside forests, which can't be seen by normal cameras, whereas a radar like this, can definitely detect them. And they're also like one of the most successful forms of radars, like I said before, because they can be like the image quality is like really, really good, and it can be used in any weather, any time. And it also does not have to be daytime; like it can be any time because it just sends out radio waves. Yeah, and it's not just important for military reconnaissance, but for like basically any application that would require imaging from like a distance. Ocean topography, volcanoes, to find underwater volcanoes, tsunamis, etc. To knowing, yeah. So they have a lot of uses. So that's why we use synthetic aperture radars. And this is a short little seminar about it. And these are my references.